To study the behavior of a function, we may need its graph. Graph of a function f from x to y, where x and y are subsets of R, is the set of points in the Cartesian plane whose coordinates are input-output pairs x f x of f. In other words, graph of f is the graph of the equation y equal to f of x. Usually, to draw the graph of a real valued function of real variable, we follow the 3 steps. 1. Make a table of pairs x f x where x in x, plot the points x f x in a Cartesian plane, draw a smooth curve through the plotted points. For example, to draw the graph of f x is equal to x square defined on the interval minus 3 3, here the values of x are from the interval minus 3 3. We cannot consider all the values. So, for convenience, prepare the table of pairs x f x taking integer values for x, say x equal to minus 3, minus 2, minus 1, 0, 1, 2 and 3. The corresponding values of f x are 9, 4, 1, 0, 1, 4 and 9. Plot the points x f x in the Cartesian plane by choosing a proper scale. Join these points by a smooth curve as in the figure. One problem arises here is, how can we assure that the shape of the curve between the plotted points is as drawn? One solution is to plot more points until the shape becomes clear. Still, in some cases, the exact shape of the curve may not be known. Actually, to sketch the graphs, more properties like continuity, differentiability, etc. of functions are to be studied. The sketching of graphs of functions will be studied in another module. Let us see how to draw the graph of the function g defined by g x is equal to 2 x plus 3 in the interval minus 2 less than or equal to x less than or equal to 1, x minus 2 whole square plus 1, 1 less than x less than or equal to 4. Here g is defined piecewise on the interval minus 2 4. On minus 2 1, the formula is 2 x plus 3 and on 1 4 it is x minus 2 the whole square plus 1. So, prepare the table of pairs x g x taking as many points as they could reveal the shapes of each portion of the graph. Here the graph of the function on minus 2 1 is a straight line segment and on 1 4 it is part of a parabola. It should be noted that the point corresponding to x equal to 1 is on the line portion of the graph and not on the parabolic portion. To emphasize this, we put a tiny circle at the beginning of the parabolic portion. Function value from a graph. We can find the value of a function from its graph if plotted on a graph paper by drawing a vertical line at the point meeting the curve. For example, consider the graph of f x equal to x square. The value of the function at x equal to 2.5 is obtained from the graph by drawing a vertical line at 2.5 to meet the curve at P and draw a horizontal line from y axis to know the value of the function. See that it is 6.25. Shifting of graphs. Here we see how the formula changes when a graph is shifted to up or down or to the right or left. The graphs of y equal to x square plus 3 and y equal to x square minus 3 are obtained by shifting the graph of y equal to x square upwards and downwards respectively by 3 units as shown. When the graph of the function y equal to x square is shifted to left by 3 units, we get the graph of y equal to x plus 3 the whole square, and to right by 3 units we get the graph of y equal to x minus 3 the whole square. The graph of f x equal to x plus 2 the whole square plus 3 is obtained by shifting the graph of f x is equal to x square to left by 2 units and then moving upwards by 3 units. Graphs of odd and even functions. A function y equal to f x is said to be even if f of x is equal to f of minus x and odd if f of minus x is equal to minus f x for every x in the domain. In these cases, both x and minus x must be in the domain. F x is equal to x square is an even function, whereas g x is equal to x cube is an odd function. In the case of even function, x f x is in the graph if and only if minus x f x is in the graph. So, the graph of even function is symmetric about x axis. On the other hand, graph of odd function is symmetric about the origin, since x f x is in the graph if and only if minus x minus f x is in the graph. See the graphs of f x is equal to x square and f x is equal to x cube. Curves which are not graphs. Every curve that can be drawn may not be the graph of a function. We know for each x in the domain there should exist a unique f x only. So, no vertical line meets the graph of a function at more than one point. See the following curves. Functions not graphable. It is not possible to draw the graph of every function effectively. Try to draw the graph of the Dirichlet's function f defined on interval 0 1 defined by f x is equal to 0 if x is rational, equal to 1 if x is irrational.